Hi, today I'm going to talk about linear versus logistic regression. They are predicting continuous or just a yes and no. Uh, so, what is a linear regression? It predicts a continuous value. The problem is that we often ask how much or what value. The output can be any real number, for example, $10.50, 95 minutes, or 2,500 square feet. An example would be to predict a house price based on square footage. The key concept here is that the output can be any number. So if you look at the diagram on the right, I produce some hypothetical data. Let's say the blue points are data from recently sold houses. The x-axis here is the square footage. Y-axis is house price in US dollars. So based on all these blue points, we use linear regression to compute the line of best fit, which is the red line. If you use mathematical formula, it will look like y equal 152.62x plus 100,530.18. Here in this simple example, the x-axis is only a square footage, but in real-world application, the input x may be multidimensional. So this slide explains logistic regression. Essentially, it predicts yes or no with a probability between 0 and 1. An example here is a financial transaction fraudulent or not, given the amount. Key concept is that this is a classification algorithm. It classifies yes or no, despite its name is a regression. So on the right side, you will see that the axis is the transaction amount. And the blue dots in the bottom are the data point we collect for legitimate transaction. And the red dots are the fraudulent transaction. And the green is the sigmoid function. It's also called logistic function. It's used to predict, to form this regression formula and predict yes or no with a probability. For example, if the transaction amount is very low, such as $2 or $3, then the probability is very close to 0. If the transaction amount is 100, then it's somewhere between 0.3 to 0.32. So as the threshold goes beyond 0.5, we think this is more likely to be a fraudulent transaction. Disclaimer for this and previous slides that the data are hypothetical and do not refer to real transaction. Here are some more real-world applications. So in healthcare, you can use an input such as some patient history to predict the probability of a certain healthcare condition. And in information technology, you read the input as email title and content and to predict if it's a spam. So those two are logistic regression. And the next two are linear regression. You can use historic staffing level versus workload to predict the value of optimum staffing level. And then in transportation sector, you can use the distance travel to predict cost of gasoline. So key takeaway is that linear regression is for predicting a value. Logistic regression predict yes and no. If you like this video, you can subscribe my channel for future videos. And for my background, I have 17 years working at Magnificent 7 company. I have a PhD degree and have won an IOI silver medal. If you just start learning Python and are considering a platform, a course, below is an affiliate link. If you use this link to purchase, they will sponsor me and you don't have to pay extra. Thank you very much. Look forward to seeing you next time.